Unlocking the future. Commercial quantum computing and AI. Quantum computing's big leap. How cloud and AI are fueling a $21 billion revolution by 2046. Here's the truth no one wants to admit. The quantum computing gold rush is already underway, and it's not just about solving Honder math. By 2046, the hardware market alone is projected to balloon to over $21 billion, with governments and tech giants racing to claim dominance in a field that could redefine everything from drug discovery to autonomous vehicles. But here's where it gets controversial. Are we witnessing a genuine technological revolution, or are we simply chasing a sci-fi dream with billion-dollar budgets? Let's break this down. In this eye-opening webinar, ID TechX's Noah Elalamy peels back the layers of quantum computing's commercial potential. He doesn't just explain what quantum computers are. He maps out why they matter now, especially when paired with AI and cloud infrastructure. Imagine a world where complex protein folding simulations that take supercomputers weeks are solved in hours. That's the promise, but here's the kicker. We're still figuring out how to bridge the gap between lab experiments and real-world applications. Key questions tackled in this session include: what makes quantum computers uniquely valuable in today's tech landscape? While classical machines crunch numbers sequentially, quantum systems leverage qubit superposition to process vast datasets in parallel. But are they truly better for everyday tasks like recommendation engines, or are we overhyping their capabilities? How are tech giants like Microsoft, Google, and AWS positioning themselves? These companies aren't just investing in hardware. They're building cloud-based quantum platforms. Think of it as a quantum Netflix for businesses. No need to own a machine, just rent access. Yet this raises a thorny question. Will open access democratize innovation or lock it behind corporate paywalls? Is quantum computing a rival to AI or its ultimate partner? Some experts argue that quantum algorithms could exponentially speed up machine learning. Others warn that AI's current success might make quantum's niche harder to justify. And this is the part most people miss. The real synergy might not be in replacing AI, but in reinventing it. The webinar draws from ID TechX's comprehensive 20-year report, which dives deep into 8 competing hardware approaches. From superconducting qubits, the current favorites, to exotic topological qubits still in the lab, each method has its own risks and rewards. For example, trapped ion systems offer high accuracy but struggle with scalability, while photonic qubits promise stability but face integration challenges. The full report even predicts which technologies will dominate by 2046, a forecast as contentious as it is fascinating. So, are we on the cusp of a quantum breakthrough? Or is this just the 21st century version of the AI winter? Consider this. In 2023, a quantum computer simulated a molecule with 12 qubits, a milestone, but still trivial for pharmaceutical companies. Meanwhile, cloud providers are already charging enterprises for quantum time, betting that good enough will eventually become revolutionary. Here's your homework. Do you believe quantum computing will deliver on its hype within a decade? Or is this a field where progress is measured in decades, not years? And if you're a business leader, should you be investing now or waiting for the dust to settle? Drop your thoughts in the comments. Let's debate what the future truly holds for this $21 billion gamble. Quantum computing. 3 major barriers to mainstream adoption. The quantum computing revolution is knocking, but can we open the door? Imagine a world where diseases are cured in a fraction of the time. Global warming is tackled with unprecedented efficiency, and logistics are optimized to near perfection. This is the promise of the useful quantum computer, poised to turbocharge our computing capabilities. Applications in drug discovery, simulating the real world, and artificial intelligence, AI, are just the beginning. But despite the excitement, quantum computing faces significant barriers before it can become mainstream. The allure of quantum computing. From a business perspective, the potential is vast. Accelerated calculations will revolutionize fields like delivery, logistics, and anything to do with real-world simulations. The synergy with AI is particularly promising, enabling faster model training and operational use. However, a journey to harnessing this power is fraught with challenges. Technical challenges, the quantum conundrum. Stabilizing qubits. The fundamental units of quantum computing, qubits, are incredibly fragile. Maintaining their state for more than microseconds without disturbance from heat, vibration, or electromagnetic fields is a significant hurdle. Current solutions, such as superchilling to near absolute zero and housing ions in vacuum chambers, require highly specialized equipment. Scaling up. Today's quantum computers typically operate with 50 to 200 physical qubits. Experts predict the need for 10,000 to over 13 million qubits for truly impactful quantum computing. IBM's Condor, with over 1,000 qubits, is a step in the right direction, but still far from the goal. Software shortage. The lack of diverse software for quantum computers is a stumbling block. Most existing applications are purpose-built, leaving innovators to develop their own software and infrastructure at considerable expense. But here's where it gets controversial. Overcoming these technical challenges is just the beginning. The real obstacles may lie in societal, cultural, and security issues that technology alone cannot solve. The bigger picture: societal and cultural challenges. Skills gap. With 3 job vacancies for every qualified applicant, the race for quantum talent is fierce. Small and medium-sized businesses may find themselves waiting for the market to catch up. Technological inequality. The high cost and operational difficulty of quantum computers risk monopolizing their benefits among corporations and well-funded entities, potentially blocking smaller businesses from competing. Infrastructure overhaul. Adopting quantum computing will necessitate significant infrastructure investments for many businesses, potentially meeting cultural resistance due to the scale of change required. Security implications. Quantum computers powerful enough to break current digital encryption are on the horizon, posing a significant threat to state security and individual privacy. Safeguards must be developed before these computers become widely available. And this is the part most people miss. While the technical hurdles are significant, it's the societal and cultural challenges that businesses can proactively address without needing vast resources. Focusing on these aspects will be equally crucial for long-term quantum success. Is AI the solution to unlocking quantum's potential? The symbiosis between quantum computing and AI could be the key to overcoming technical hurdles. AI can accelerate quantum computing development, and in return, quantum can significantly boost AI's capabilities. However, for businesses eager to capitalize on quantum opportunities, tackling the societal and cultural challenges head-on will be paramount. Now it's your turn. Do you think the societal challenges of quantum computing can be overcome without significant government intervention? How do you envision the balance between technological advancement and societal readiness playing out in the quantum computing space? Share your thoughts on whether the potential benefits of quantum computing outweigh the challenges it poses to individual privacy and security. Quantum computing, humanity's next fire. BofA Insights. Quantum computing is nothing short of revolutionary, quite literally. It could mark humanity's most significant leap since the discovery of fire, according to analysts at Bank of America. In a recent insightful note, they drew a parallel that underscores the transformative potential of quantum computing, suggesting it could propel human knowledge and development at unprecedented speeds. This could be the biggest revolution for humanity since discovering fire, the analysts wrote. A technology that can perform endless complex calculations in zero time, warp-speeding human knowledge and development. Tracing back to early human history, the controlled use of fire is believed to have begun hundreds of thousands of years ago, possibly even 1 million years back. So, how does quantum computing stack up against this ancient milestone? Theoretically, there's no calculation it can't tackle, BofA asserts. This groundbreaking technology holds the promise of revolutionizing various sectors, from creating new drugs and materials to enhancing longevity, encryption, and logistics. Moreover, the ongoing artificial intelligence AI revolution stands to gain immensely from quantum computing, and vice versa. Gen AI can help speed up the development and testing time of quantum systems, which could take AI model training to the level of artificial superintelligence, BofA points out. Quantum computing has already achieved several landmark milestones. In 2023, Google announced that its Sycamore quantum processor completed a calculation in just 6 seconds, a task that would have taken the world's most powerful supercomputer a staggering 47 years.
In December, Google further showcased its progress with the Willow quantum chip, solving a problem in under 5 minutes that would have taken the fastest supercomputer 10 septillion years to crack. Despite these advancements, a quantum computer has yet to solve a practical, real-world problem faster than a classical computer. The primary hurdle remains the instability of qubits, the fundamental units of quantum information, which are prone to noise or disturbances that introduce computation errors. NVIDIA CEO Jensen Huang has been cautious about the immediate prospects of quantum computing, stating in January that the most exciting developments are still over a decade away. In March, he tempered expectations, clarifying that quantum computing isn't meant to outperform classical computers for everyday tasks like spreadsheets. Rob Schoelkopf, co-founder and chief scientist of Quantum Circuits, also cautions that progress in quantum computing will be gradual rather than sudden. We're going to be turning the volume steadily, and we can start to hear the music now, and eventually everyone will be able to hear the music, he predicted. Beyond its technological implications, quantum computing also has significant geopolitical ramifications. As the technology advances, it has the potential to level the playing field in processing power, an area where the US currently holds a lead. Whoever wins the quantum race will gain an unprecedented geopolitical, technological, and economic advantage, BofA analysts warn. As we stand on the brink of this quantum revolution, the possibilities are as boundless as they are transformative. The question remains, are we ready to harness this fire of a new era?